My name is Alexis Richardson, and I am, among other things, the CEO and founder of Weaveworks, a software company based in Shoreditch and San Francisco. We make cloud-native tools for containers, Kubernetes, Prometheus. If you want to talk about that, please talk to me. I'm also the chairperson of something called the Technical Committee for the CNCF. Does anyone know what the CNCF is? One person knows what the CNCF is. CNCF is part of the Linux Foundation. It's the home of Kubernetes. Who knows what Kubernetes is? Great. Because I'm going to be talking about CICD for Kubernetes today, basically. We call it GitOps for reasons that I will explain. It's just a variation of DevOps, modernization, if you will. And it's all about going from a few deployments a month or a week to many, many, many deployments a day. Can I have a show of hands? If you're doing deployment, if your team has an app that you're responsible for, how many people change it more than once a day and deploy more than once a day? Yeah, it's probably about 15%. I think in a few years' time, that number's going to change. And what's allowing that is the flexibility and power of these new technologies that are arriving on the scene today. Kubernetes is the most important and most best known, along with Docker. They provide you with a lot of automation and flexibility, which lets you introduce a whole new layer of tooling to make these changes more frequent. So I'm going to start with an example. Okay. This is a company called Cordoba. They're based in San Francisco. And they do a really cool product, which is a website for what Americans call big marketing brands who do something called localization. So if you make, say, clothes, and your advertising depends on people wearing those clothes in order to encourage people to realize how nice they look, one thing you might want to do is have variations on how you present that to people in different countries, localization. And Cordoba do localization for these big shopping brands, but powered by machine learning. So it's kind of a combination of traditional online marketing from the 1990s, 2000s, with the latest and greatest in analytics. And when we started working with them, they were already starting to use Kubernetes. And they had attached Kubernetes to Jenkins on Google Cloud, and they started using Weave. And today, by the way, I'm not going to try and force you or sell you on a commercial product. There is an open source path for everything that I'm going to show you. There's actually several paths. I'm going to talk about patterns as much as about products. But in this particular thing, they are using our implementation of this stuff. And this is a picture they sent me of their rate of fixing bugs and responding to consumer requests. And before they started using Weave, they were on this trajectory, and then they started using our software, and they went up to here in terms of their rate, and it ends up looking like this, and this is the kind of the key numbers. So they basically doubled their team's productivity, and when I asked them what was going on there, they said, the real benefit to us is we used to do deployments, each one took about 30 minutes to do, and sometimes they would break. So we would do 1 or 2 a week, and when we were doing a deployment, everybody would just have to kind of hold their breath. And then if something broke, we'd all have to kind of go into full alert to try and fix it, because there wasn't any rollback as such. They would have to either figure out what had gone wrong and either kind of keep going or kind of go back and start again, maybe rebuild the whole thing. In other words, a bit of a nightmare. And now they've got something which is automated and instantaneous and can roll back. And it's programmatic and repeatable, not based on scripts. It's very hard to make it go wrong, which means that all of that sort of developer freeze time that they had of like, let's wait for the deployment to finish, could be freed up by thinking about the application once more. So they stopped worrying about infrastructure and focused on the application. And they started to gain confidence in doing more and more and more deployments. And now they're doing more than 30 a day, and this is quite good for a team which consists of about 20 developers split up into about 5 teams. Okay? So that allows them to do things like experiment. What if this would work in China? Let's try that. Oh, no, it doesn't work. Let's roll back. And they can do this really fast. They're very excited about this. And this is part of the GitOps is just an example of the larger DevOps picture. If you read about continuous deployment in the space from people like Jez Humble and others, there's lots of people who've written down over years and years and years how there's a kind of phase shift that occurs as you go from a few rare deployments to lots per day, and the confidence of that gives you that all of these other numbers start to shoot up. So what I'm saying here is it's really this that's enabled them to get good results in terms of productivity. So what is GitOps? Building on the idea of DevOps. But perhaps a slight shift in focus. In DevOps, we were talking about infrastructure as code. So operations folks who are responsible for infrastructure start to think about how the system works in relation to code and become coders, developers, hence DevOps. With what we're seeing today with cloud-native tooling like Kubernetes is, if anything, kind of the other way around, where developers are being encouraged to take ownership of some operational functions, which is leading to ultimately the same result. And there are teams like, one of our teams that we work with is Lyft, the Uber competitor. I asked them, so what's your structure? Do you have operations people and developers? How does it work? And they said, everybody is DevOps. And I don't believe that every single person in that team, it's a very large team, has exactly the same function, but they think of themselves as being just kind of overlapping. One big team, which is really cool. And the key idea here is, and this is also not a new idea, using Git as a single source of truth for the whole system. And this idea first appears about 2005, 2006, of course, on one of the Martin Fowler blog posts. He's very good at kind of writing things down before other people do. Talking about using source control as a way of expressing what you want to do in your system. And you can see this is sort of starting to happen with web apps. This is something that didn't happen with old client-server applications. And now we have these systems where we actually are interested in uptime. We want to maintain a common experience, possibly across the globe. It becomes very important to know what the system actually is supposed to do. So we start to store it in source control. And this idea evolves and evolves as continuous integration starts to appear on the landscape. Testing becomes very important. Automated testing becomes very important. Suddenly, at scale, having any kind of system without automated testing and build becomes unfeasible. And now today, 70% plus people use CI. And so then it becomes natural to tie that to Git. And so there's this prevalence in the DevOps world of you change things in Git, your CI picks up, and you roll out artifacts, or you get artifacts that you can roll out. So you've taken that basic pattern and just kind of expanded it. We ourselves as a company or a startup, we've got about 45 staff, of whom half are basically all SREs doing development and operations and open source and all the cool things. And we've learned through enormous pain in the last few years of running Kubernetes and anger on Amazon at scale that the pipeline has to be automated, complete, end-to-end. It has to have everything. There's no point in having CI and then having a manual deployment phase. You've got to make it monitoring and security right at the beginning. Otherwise, you have no idea what happens when things go wrong. And really critical, everything has to be version controlled and stored in one place, which is one source of truth, not two. If you have two sources of truth and something goes wrong, you are in trouble. And I'll tell you some more examples of that in a minute. And this is a picture I found to just illustrate the idea that DevOps is an evolution. Some ideas, some practices, some technologies, all these things at once, co-evolving. That's the expression that Simon Wardley would use here. Practices and tools are co-evolving. And we start off with some people at some meetups, and all of a sudden you've got people at Velocity, and then you've got Chef and Puppet appearing, and so on and so on. There's the Phoenix Project, great book if you haven't read it. And now we have Cloud Native. This image, by the way, is from a woman called Helen Beale at Ranger 4, a DevOps consultancy. So what is Kubernetes bringing to the party? Declarative infrastructure. If you read about infrastructure as code, which is basically the idea that instead of having each machine hard-coded with weird config files all over the place, you can have a more programmatic approach to building your machine or your machine image in the cloud. It splits off into two different schools of thought, the declarative and the imperative. And the imperative looks more like how machines used to be built. And the declarative, which is exemplified by, I believe, Puppet, for example, basically says what the end state should look like and lets the system figure out how to get there on a per machine basis. Kubernetes does the same thing, but at the level of the whole application and at the level of containers rather than underlying machines. So this is a picture actually of a web app with an RSS reader component and an Nginx component. And this format you probably recognize as YAMLs, the famous horrific config format that's used in most cloud-native things today. The key point is, however horrific it may be, it is declarative, which means that it can describe an end state, and the Kubernetes orchestrator can understand that and then enforce that a system obeys with the constraints of that end state. And this isn't particularly a great example, but I probably could have something with, it might say there are 4 replicas for Redis. And then Kubernetes will notice if a Redis blows up, then, and there's only 3, it will spot that and will start another Redis for you. Or if somehow you end up with too many, it will shut one down. Is this making sense? So, let me tell you a story. I mentioned about bitter lessons of having automated pipelines and observability joined together. We, about a year and a half ago, we'd been started running our system in anger for about 6 to 12 months. And sitting in the office one bright spring day, and one of the developers suddenly says, I think I might be about to wipe out the whole system. If I press this key, then I'm going to wipe out everything, I think. I'm worried that's probably what's going to happen, at which point I stood up and said, please don't do that. What are you? Anyway, the next thing I heard was click, followed by oops. And then, oh, our system's gone. For fuck's sake. Anyway, then the whole SRE team had to come together and do incident management. And we got the whole system back up again in 45 minutes. Now, this is bringing up all of the application state. The data's on disk. Multiple Amazon zones, multiple stages, including production, actual users, the lot of a very complicated system involving Kubernetes and Prometheus and FluentD and SQS and NAS and God knows what else. Tons of things. And we were very pleased with this. It just worked. And the reason was we had not only the code and the config of the machines, but also the entire application state and the monitoring state and the health checks all stored in Git. So one key idea about GitOps is the more about your desired state of your system that you can have in Git, the more you can get back consistently. And the other thing is, obviously, Git is a social tool. So when you have lots of people working together, you can see why decisions were made. I mean, hopefully preaching to the choir here. And what we have today is major minor changes don't go through kubectl on Kubernetes. So people who don't know Kubernetes, kubectl, as Kelsey Hightower says, is like SSH for Kubernetes. You kind of open up a backdoor and you script Kubernetes using a command tool from the command line. Kubectl lets you change how Kubernetes is working. So we don't want people to do that. We want people to go through Git, even for production changes. Now this is a guideline, okay? It's like, above all, don't do anything really stupid. If you need to break the rules, break them. But we try and stick to the rules. So probably 95% of the time we stick to this, even in crises. The other thing you can do is, and this is where observability comes in, you can compare your observed state with your desired state. Now, Kubernetes is capable of doing that for some things, and that is, in fact, what orchestration is. The YAML I showed you is compared with the running state. So, for instance, I can tell whether I have 3 Redis replicas or 4 and do the right thing. We just have expanded what you can do with that with diff tools and sync tools and things like this. So GitOps is just following the DevOps rulebook, which is your config is code is version controlled, config is version controlled too. What can be described, therefore, can be automated, provided you have tools that understand how to reconcile desired and observed state. And what we're trying to do is maximize the scope of what you can describe and observe so that you can reconcile everything. Now, when I say automation, another key point, I'm not saying, please stop doing your jobs and let some mysterious piece of software take over and automate everything. In practice, a lot of things are semi-automated, or there's a manual step, or there's an approval step, or there's a staging piece. But the more automation you have, the easier it is to decide where that should be, okay? We do this even with things like monitoring tools as well. So it's not just config and code, but also policies about deployment, dashboards as well. Once you've got the ability to describe your whole system this way, you can start diffing it. Again, this is not a completely new idea. We're now getting into the realm of fairly recent. I believe Puppet, Ansible have tools a bit like this. You periodically compare your desired state with your observed state in relation to things that Kubernetes itself can't see, and you fire a diff alert. In this case, this is popping up on our Slack SRE channel saying something is wrong. And obviously, this is actually quite an old image. We've got slightly richer reports now, and there's a link to the dashboard and the playbook and so on. So you can sort of see how this can create a joined-up lifecycle. So that's the core idea. A good presentation of the core ideas, and this is where I said, not pitching a product, there's a pattern here, is presented by Kelsey Hightower, who's probably the most well-known advocate for Kubernetes. He did a really good keynote at KubeCon in Austin just a couple of months ago, which is on YouTube. You can go find it very easily. In fact, you can go to our blog and you'll see a link to it. The world is no longer envisaged as a machine installation. It's now seen as a repo. Because that's what moving if you say, my system's observed state must be correct, it must be what's the desired state as well, then I can say that the world is what's in my repo. For the things that are important. Everything else is incidental. And he provides a demo, which gives some guidelines to how to do this yourself. In his case, he's doing it with GKE and GitHub, but you can do it with other cloud tools and other repos, Bitbucket, so on. The key points that Kelsey makes in his talk, which I'll repeat for you here, is that once you've got your Kubernetes, you really want to have CD, continuous deployment. And CI is not the same thing as CD. There's a limited number of CD tools out there. I will describe one later. Weaveworks, but there's also Spinnaker. There's an online service called CodeFresh. There's a few other things kicking around. He describes the goal, which is very similar to how we see it as a developer. I want to make a pull request, and really I just want to get given a URL to see what the results of my change were. And then bonus points for the operational back-end tooling. Give me metrics, give me visibility, and then I don't have to open up the back door and use kubectl anymore. And so this is really useful because it means that a new developer can join the team who knows GitHub and be productive on day one, which is really cool. You don't need to learn Kubernetes or learn Cloud Native or learn Prometheus to do this or learn Grafana. Plus, and again, emphasizing something that already exists, all your changes are audited in Git, which also has these really nice features like roles-based access control and security and who does what. You know, people who are our customers are using this technology, this approach for things like compliance, PCI, HIPAA, and SOX, because they can go and see who made changes to the system at certain times in here. And when you show the auditor this, then they go, oh, well, that's amazing. I didn't know you could do that. And bear in mind that this world of HIPAA compliance is one which is actually full of crappy commercial products that don't do half the things they're supposed to, and the things that they actually do, they do wrong. It's just a general world of psychopathic bullshit. So actually using a nice clean tool like Git is really helpful. Okay, so let's unpack the GitOps concept a little bit more. I'm going to talk about what I call the 3 pillars of GitOps, which are shown here in these brightly colored rectangles. Pipelines, observability, and control. And sometimes when I do this talk about observability being a concept that arose from the 60s with something called, various kind of things like decision theory and control theory that arose at the time. But observability and controllability are dual concepts. A system that is observable should be controllable. That's an interesting thing to go and research if you have some time. So let's talk about each of these. Joined up pipelines. This has 3 parts. As I mentioned, Git has to be the head of this, or an equivalent system. CI/CD and release automation, not the same thing, okay? CI is what you do for testing, building. There's a pattern, which I think of as an anti-pattern, which I call CI-ops, which is when you let the CI system drive your push to production, because you write more scripts that take your built assets and roll them out that way. If that crashes, you do not know what state you're in. Continuous deployment is using specialized programmatic technologies to orchestrate the relationship between what is in your built artifacts, which would be containers in the case of Kubernetes, but it could be VMs or it could even be other things, and what's running in your real system, which in Kubernetes case is a cluster. I'll be describing more about that in a minute. And release automation is an interesting concept. I mention it for two reasons. One, because if you're interested in how enterprises do this, and ultimately that's quite important, release automation is an actual product category. There are things that you can buy that help you do releases and manage who did what when, going back 15 or 20 years. And there are things that are happening now with Kubernetes that resemble what those products do. But the other reason is, as you do more sophisticated types of CI/CD, you find that you actually want to differentiate between a deployment and a release. A deployment being moving an artifact so that it's incarnated and running in the cluster somewhere, and then a release being actually having it exposed in production to users. Because you might have 5 or 6 different concurrent deployments, of which only 1 or 2 are exposed to users. In the case of 2, classic examples of this are A/B testing, when you have 2 versions of the system, you're checking them concurrently, and you're splitting half and half of your users, let's say, and then giving them variations of the system so you can try out ideas. Another one is blue-green deployment, where you start off with you roll out a new version, you've got it in parallel with your old version in the production system, and then you flip all the traffic over. And you keep the old one there in case you need to roll back quickly. And the other one, of course, is canary. Does everyone know what a canary is? So canary concept of canary in the coal mine. You send a small thing into your production system and you let that live or die, and then based on that you decide whether to roll out the whole thing. So what that means in practice is I roll out my change. I tell my router or my traffic manager or my load balancer, hey, there's a new thing here. Why don't you send 1% of the traffic to that? Well, let's watch what happens when that happens. Is the performance improving? Is the user having a better time? Do we think this is the right thing to do? Yes, okay, let's roll more traffic over. Oh, now hang on a second. We observe in our 1% canary that, oh, look, the queues are getting blocked up. Something's backing up. Something's gone wrong. Oh, dear. We've introduced a bug. Let's not actually roll out any more of that. Let's shut the canary down. So that's the concept of release management. So to do this, you've got to have your pipeline. This is a amateurish picture of a pipeline. Little acronym to help you remember is A, B, C, D, E. Your app tools like your IDE or your Git, and then your build tool. There are lots of really great build tools out there. So you can choose your own adventure here. We use Circle CI at Weaveworks. It's a nice little tool. Another very similar one is Travis CI. There is, of course, Jenkins, which is very widespread, and the commercial company doing very well, CloudBees, which is the Jenkins company. There are other tools like Shippable, GitLab. Most of the big clouds now have their own tool. There's a Google Container Builder, for example. And because we're in the container world of cloud native, you generate containers from your build and config artifacts. And then you've got to get these into your running cluster. So that's the deployment and release automation step. So that's your pipeline. OK. This is quite an interesting bit, because now I'm going to say a few slightly more detailed things about Kubernetes itself. Right. So Kubernetes has this concept which was introduced about 1.5 years ago called an operator. And an operator is essentially an agent that lives inside Kubernetes and shares its life cycle and takes responsibility for starting and stopping things that Kubernetes itself does not natively know how to do. So it's really a customization tool for adding things to Kubernetes in a way that's consistent with how it operates. And there are examples of operators out there, like, for example, the etcd operator or the Prometheus operator. We've written a service for doing multi-tenant monitoring with Prometheus, which is essentially as a Prometheus operator, starting up as many Prometheus instances as you like in Kubernetes and managing that and scaling it up and scaling it down and making it multi-tenanted. So that's the kind of thing an operator does. You can do deployment using an operator, because what you're doing is instead of letting your CI tool push artifacts willy-nilly into your running system, you actually let something live in here, take on the role of being responsible for deployment, and be responsible for looking both at the Git code and config and at the service and what Kubernetes thinks has been deployed, and making sure that they are the same. Do you see the difference? So this is an active process. It's running all the time. It's checking this periodically. It's checking this periodically. And if they're different, it's reconciling them. So you have desired state, observed state, and it's making sure they are the same. So this is extending the core idea of orchestration. So it's really a deployment orchestration operator. This is very different from pushing things and hoping that it will run, okay? Does this make sense? I hope so. So just to recap, we want to do GitOps. We want to have everything be in Git. So config is code and everything is config. We're in a declarative world, so that's relatively straightforward. And therefore, everything has to be version controlled. And again, something else that the operator has to do is record changes that it makes as it's doing the deployment so that the desired state and the observed state are the same. So that when you've actually completed the deployment, you can go and look at Git, and the deployment operator will have updated everything saying this is now moved from staging into production. And these are the images that we're running, and they're associated with these services, and now we're in a correct state. After that, things may well go wrong, but you're in a correct state at that point. If you want to do this yourself and you don't have any config to hand, you can extract it. There's a tool for this, which is called, excitingly, kubectl export. And this, if you whittle around with this, you can get your Kubernetes to give you things that you may not have in terms of your config. Okay? And you should look at what it gives you, because it may not have the things that you expect. Okay, this is quite a nice example. What about secrets? So Kubernetes is intended to run large-scale multi-tenant, multi-user, multi-everything systems, which means that we need to care about security, and we also need to care about who gets to mess with the system at different times. So we have secrets which let different people do certain things to the system at different points. And those secrets might need to be rotated, for instance. So let's say that somebody leaves the company to go and get an exciting job at another company, and so they then have credentials into the system. We might rotate our secrets out so they can no longer get in through the back door. And in GitOps, we want to keep everything about our running state and our desired state in Git. How do we do secrets? Because it's bad practice to put secrets in Git, because people can go and find them there. And they're not secret anymore. So Bitnami, another company that we work with, came up with this really cool solution called sealed secrets, in which you encrypt the secret before you put it into Git, and then you have a mechanism so that Kubernetes can decrypt it. Pretty cool, huh? So effectively, you're sending secrets inside sealed envelopes when you do a deployment, and you can do once you've got that, you can do everything exactly the way I've described as if it was unencrypted. So that when you have a disaster recovery situation, your whole system blows up, all you need is the initial private key to unlock all the secrets in the cluster, which means that you can recover your full state from Git. And the way that works is, it's another operator. It's the same technology that we use to run monitoring, Cassandra, MySQL, Redis, and Flux deployment in Kubernetes clusters. We can also use to do encryption and decryption. So thumbs up. So how do you organize your code and repos if you want to do GitOps? We typically recommend that you split your config off into a separate repo, because what you don't want to do is when you update your config, trigger a build. Otherwise, also split things up by service and application as much as you can. And different branches per environment. So we typically will see staging and prod, or 3 or 4 stages, different kinds of staging. It's very important to be able to split staging from production so that you can make sure that everything is correct in your staging system before it runs in production. I hope that's not too much of a teaching you to suck eggs type of statement, but it's very easy to make mistakes, even in these more advanced systems that you need to check in staging. And then push all your changes, including health checks, to branches first. Why would we push health checks into a staging branch? Because if you made a mistake in your health check, if that was wrong, and it accidentally told you your whole system was unhealthy and you were in production, it would shut the whole thing down. Whoops. So you want to actually check both the monitoring and the running system, which is why we're saying GitOps is more than just infrastructure as code, it's also health checks as code, monitoring as code, applications as code, everything as config. Lastly, how do you do production changes? You do a merge. You go from staging to prod in Git, and off you go. The same thing happens in production. It's not driven by CI, it's driven by Git and the deployment operator. Because the deployment operator goes, aha, something has changed. Now I need to update the running system. And here's a picture of that. So this here is your fairly typical CICD pipeline as currently conceived in most of the DevOps industry. And here's what you get by adding the concepts I've been describing of having a deployment operator be responsible for reconciling changes that you intend to roll out in production with your actual observed state. So you're adding this to this when you do GitOps, basically. Okay. So the key thing here is, the really important bit, when you do a rollout into production and you do a merge, the configs will get changed, and the images that you want to roll out will be changed in the config, and this will notice that, and it'll go, ah, the desired state and the observed state are different. I need to do an update. And it'll keep working on that until it's correct. Okay. So that's the pipelines piece, the most detailed. The second piece is observability, which I hope will be very intuitive. So observability, it's an utility, it's a property of your system. It's not a thing that you do. You don't do observability. Well, you do it if you're a vendor, I guess. As an owner of a system, you don't do observability. It is desirable that your system is observable in the same way as it's desirable that it's secure. It's desirable that it's available. But when it comes down to it, it's really bringing together a few core tools, monitoring, logging, tracing, events, visualization, error reporting, etc., to create the most comprehensive view possible into your system. The key difference between observability and monitoring is, whoops, hang on, I'll go back to that in a minute. Just jump a couple of slides ahead. The key difference between observability and monitoring is expressed by Charity. She's here this afternoon, by the way, so please go to her talk. Charity's amazing, talking about observability. Monitoring is a tool that you use to tell you things that you already know are important, and you're trying to make sure that all the critical things you may want to get alerted on are in your monitoring system, and just those so you don't get overwhelmed. Observability is everything else that you might ask after you start to try and understand what's going on in the system, especially if you are a developer. So how does that play out here? Here's a nice rule of thumb from John. Observability-driven development. Don't merge that pull request unless you know you can check that it's correct or incorrect after you've merged it. So you want to be able to use your view into the system to verify that what you did is correct. This is particularly important with a tool like Kubernetes because it's automated, it's virtualized, it's running everywhere, it's doing a lot of things for you. So you don't have that old way of just checking the app is up, except going to the website. But if you want to check other things about it, like has the right number of replicas or something, you need to look at it. And this is a rather jokey comment, but I think it's not. It's also serious. I mean, it's like TDD for production. It's the whole concept of production is the new testing, which is obviously an interesting idea. So observability is intended to encompass a lot of things. End user happiness. When I make a change, does it make my user's experience better or worse? How is that user experience correlated with what I'm seeing in the logs, traces, etc. And this is really important, really, 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 really important. The old way of doing operations when you had dev and ops teams separated was you give people a rule book, a playbook, a run book, and they tell you when things are wrong and they try and remedy them, and if they can't fix them, they bring in the dev team. With the concept of developers being partly responsible for operations, as the example at Lyft, the idea is that the team who's responsible should be looking for problems before they happen, ideally. Because often systems start behaving oddly before they actually go wrong. So if you are in the habit of observing your system and asking questions of the running system, you may be able to validate whether it's healthy or becoming unhealthy before things go bad. It's a very similar concept to the idea of preventative medicine being ultimately a lot cheaper than taking people to the hospital. And as Charity says, it's about understanding your system if you're the owner of it. So that concept of understanding leads us in GitOps to have different kind of dashboard, which doesn't only have, sorry, this is rather a bad picture, this is a Lyft thing. It doesn't only have metrics, but also has logging events, so we can correlate activity with results. And here's a picture from brief product plug, our own product screen, where you do a deployment and you see the results immediately in your metrics. And that allows you to do more of the same deployment in a release or roll things back if things are not going well. So that's the concept of a GitOps dashboard that is emerging, where you're combining different aspects of a system to be able to make better decisions faster. And so the last pillar is control, which is the opposite of observability. It's really about how you change things. And it comes down to this concept, which I've rattled on about a few times. Is the desired state the same as the observed state? And if I make a change, if I want to change this, how do I change that to change this? So there's various ways that can happen. Orchestration. When that's not working, you can use diff and sync tools, and if all else fails, use kubectl. What we'd like to do is be in a world where we can do something like kubectl directly to the system here, and introduce a git commit stage. So I get the experience of messing with my running system, but I'm actually obeying the rules of GitOps so that I don't get out of sync with my desired state. That's an interesting problem to solve. And here are some examples of the kind of changes we're talking about. Systems not responsive, roll back to the desired state. Are my metrics telling me that my release is too slow or too fast? Are my diff alerts firing? Is something coming up in chat ops and so on? I'm not going to dwell on this because I'm a bit low on time. So this leads you to a service lifecycle, which I want to talk about for a few minutes. So I talked about desired state and observed state and checking the difference between them. This actually drives a cycle. So you go from Git into Kubernetes, you monitor and log it, and you then operate based on that, and this is shown here. So this is really a picture to try and show you conceptually what I think you are doing when you do operations if you are an SRE doing GitOps. This is what everybody should be doing. You've got these phases that you're going through, and you have an endless cycle. And the objective is to go around this as fast as possible. The more you can go around this quickly, the more you can iterate quickly with and make your business happy, because that's the idea. And therefore, the more you can make your customers happy. So I start from Git. I update something. I do a release. I'm now in Kubernetes. I observe it. These are the tools I'm using. They do all kinds of different things. So I need to orientate myself and make decisions about what to do. That's the operational role. That might be automated, or it might be a human, or it might be dashboards and humans. And then I act by updating something, and then I'm back in Git, because that's the place where all my actions must land, and then we go around again. So operations is a simple cycle that goes round and round and round like this for everything. So if everybody can master that, then they can do cloud-native operations. If you're a developer, they can do it very fast. You can go from a couple of deployments a week to 30 or 40 a day in a small team. So a few end observations to kind of wrap up the talk. One is a kind of So you're like, what is the sort of core idea here? That is that if you can describe and observe things, then you can control and automate them, which is what Kubernetes is doing for you with orchestration, reconciling desired and observed state. It's what we're doing with the Weaveworks open source deployment orchestrator, desired and observed state. It's what the sealed secrets are doing from Bitnami. It's what you should be doing for the whole stack. Indeed, only what you can describe and observe can be automated. If you can't describe and observe it, you can't automate it. So what are the core principles? What must you do? There's really these three things. You absolutely must be declarative. It's very, very difficult to do this with idempotent imperative scripts. You must do all the Git review melodrama in order to actually get changes into the system. The upside of this is you can ditch a whole load of change management and compliance gubbins that you might have had to use before. Don't use kubectl directly if you can avoid it. And finally, you've got to drive the difference between the desired and the observed state to consistency, to convergence, which is provided by things like the operator. Now, if you want to go and do this, there are three ways you can do it today. One is you can go and use our product, which has a free tier, which combines deployment and observability to do some of the things I've talked about. Or if you're one of those people who absolutely must do the open source thing first, we have an open source deployment operator called Weaveworks. Or you can go watch Kelsey's demo, which misses out this bit, but actually has kind of 75% of the core ideas there as well. And these are all consistent with each other. They're not competing approaches. Okay, this is more decomposed. You can sort of see the machinery and learn more about how it works, which is how Kelsey loves to do things. When you realize that it doesn't kind of make sense to be programmatic, you might want to use an operator. And if you want to have a product, well, go ahead. And so what are we doing here? We're taking operational concepts and practices and tools and putting them in the hands of developers. Because if you can merge a pull request, in my view, then you are an app developer. And if you use cloud-native tools, you can describe them in Git. So you can operate them in Git too. That's what GitOps gets you. And by the way, GitHub is very popular. It's got about 25 million users now, and I think there'll be about 100 million in no time. So, does anyone have any questions? Thank you for listening to me about this. Appreciate it. Hello.
I have a question about rapid config changes, for example, kill switches or like feature bubbles.
Okay.
Would you suggest, basically in our company we have like a requirement that a few seconds change needs to go like immediately. Would you still suggest doing those changes through GitHub?
Yes. That's what we do.
Okay, and then you do the whole deployment pipeline?
That's what we do at the moment, yeah. We do the whole thing, just push it straight through.
But then if like my product builds in like 2 minutes or something, I need to wait those 2 minutes plus like deployment.
Yeah,
plus,
yeah.
like
So,
unit tests and all other tests.
right, ours is a bit faster than that, but there is always going to be some interval. And that interval might be too long. So what do you do if the interval is too long to do the update in Git?
Yeah.
So that's where I was going with this thing about the unsolved problem. Do you know the difference between pessimistic and optimistic concurrency? So with pessimistic concurrency, a pessimistic approach to this would be to say you concurrently change the running system and you change Git, and then you make sure that the Git change is pushed through so it's the same as the running system. So the whole thing's like a two-phase commit across Git and the running system, which will be slower. You could imagine doing it optimistically, where you make the change to the running system, and then afterwards it tries to update Git for you. And then if something goes wrong, it tells you that didn't work out. Now, that obviously has some downsides, but I think that would be the way to make it faster. But it's an unsolved problem. Anyone else got a question? Hello.
How would you sell this to the senior people in an organization?
I think the best way to do it is through the examples of people doubling their productivity by introducing faster release cycles. And also talking through, so if you go to my blog, the latest blog on GitOps, which I published just this week, which is on Weaveworks blog. In fact, hang on a sec. So this is make a note of this address, and you'll find that there are some blog posts about GitOps on it that I recommend reading. In the latest one, there is a link to another blog post by Adrian Collier, who is on the board of our company. Adrian writes an excellent blog post, called the Daily Paper, in which he goes through technical papers and explains them to people. And he wrote one last year on continuous experimentation, which I recommend reading. And that basically talks about how once you reach a certain velocity in terms of your ability to deploy n times per day or per hour, you can start to experiment very quickly. And what kind of experiments might you do? Well, for the business, they might be things like A/B testing. Let's try out 2 different things for our customers, or you can have, let's try this out on our premium customers first and see if they like it. There's also just the very basic, which is shown in my example, customer response time reduced by about 50%. So if a customer calls up and says, you've got a spelling mistake on my form and I'm offended, you can fix it twice as fast. And then also fixing issues twice as fast. The other one that I mentioned is compliance. Doing all of this in such a way that you're lowering your cost of compliance is actually very compelling from a business perspective. So velocity and compliance. Anyone else? Would anyone like to say anything at all?
That was awesome. Thanks.
Thank you very much. Okay.